In this question, we're told that the number of bottles of red wine sold by a local supermarket over a 2-week period are shown below. We're asked initially to display this data in an ordered stem and leaf diagram. Okay, so something you've been doing since GCSE. I always do this in 2 steps. So firstly, I just want to collect the data as quick as possible, and then I'll order it afterwards. So taking each of these, 22 and 14 are going to go into these rows. So the stem of a 2 is the tens digit, and then the leaf of the 2 is the unit. So 22 and 14, followed by 11, 33, 32, 45. 4 is going to go at the very top with a 0 in the tens column. And then we'll fill in the rest of the values. So 12, 13, 20, 27, 44, 30, and 15. Okay, from here I can just quickly order each of these rows individually. It's a lot easier than trying to order the whole list of numbers at the very beginning. So the second row is going to be 1, 2, 3, 4, 5. This row is going to be 0, 2, 7, 0, 2, 3, and 4, 5. All right, nice and easy. Stem and leaf diagrams, we're going to need a key. So just any value to represent something on the left-hand side of the vertical line, something on the right-hand side of the vertical line, and the number it represents. So 1 bar 7 equals 17. Part B of the question, we've been asked to calculate the mean and standard deviation of the data. These should go straight into your calculator. Put them into list 1, and we'll put 1s for the frequencies in list 2. That will bring up all the necessary numbers on your summary screen. And I'm just pulling this straight from my summary screen. The sum of x is 322, the frequency or the n value is 14, and when I divide them, I get an x bar, I get a mean of 23. Exactly the same thing with the standard deviation. Here I'm showing the formula that I'm going to be using. If this is a 1-mark question, you can just write down the final answers. If there's more than 1 mark available, I recommend that you do show where the numbers have been substituted. All of this is on the summary screens, so you're not going to make a mistake. You just need to put those values in. Standard deviation is going to be 12.11. In part C, we're asked to find the median and the quartiles of the data and to use them to determine if there's any outliers. Okay, so let's start by finding the positions that we need. Q1, the lower quartile, its position, we're going to use n plus 1 divided by 4, gets us 3.75. Q1 is in between the 3rd and the 4th value. Q2 is n plus 1 divided by 2. That gets us 7.5, in between the 7th and the 8th value. Q3 is going to be 3 times the Q1 position, 3 times n plus 1 over 4. So the values that are going to be matched up with these, 12.5, 21, and 32.5. So the lower quartile, the median, the upper quartile. We've been asked to determine whether there's any outliers, so we're going to use our standard outlier boundary calculation. The interquartile range is Q3 minus Q1. In this case, it's 20. We're going to take the lower quartile and subtract 1.5 times that interquartile range. Any values smaller than that will be outliers. So that outlier boundary is negative 17.5. There are no values smaller than this. The upper outlier boundary we're going to find by taking Q3, 32.5, and adding on 1.5 times the interquartile range. That's going to give us 62.5. Any values above this would be outliers. Once again, there's no values beyond this. So actually, for this data set, there are no outliers, not according to the outlier calculation that we've used. In the last part, we've been asked to draw a suitably labelled box plot for this data. So we just need to get on the lower quartile, 12.5, the median, which is 21, and the upper quartile, which is 32.5. There's no outliers, so we don't need any asterisks or squares, but we do need to mark off the lowest value. The lowest value in this case is 4, and the highest value is 45. So here's the box plot, accurately labeled.